This lesson is called Interpreting Graphs of Proportional Relationships. We're going to be reading stories from the graphs of proportional relationships. The warm-up says, here's a graph that represents a proportional relationship. Go ahead and think about, what does it mean to have a proportional relationship represented in a graph? A graph representing a proportional relationship is linear and it passes through the point 0, 0, also known as the origin. Number 1 says, invent a situation that could be represented by this graph. So something that could help us invent a situation represented by this graph is finding the unit rate of this graph. Now I know it's going to have a unit rate because we know it's a proportional relationship displayed by this graph. Because again, it's linear and it passes through the origin. So let's find the unit rate. Something that's going to help us find the unit rate is identifying this darkened point right here. You can really use any one of the points at perfect little intersections on the coordinate grid. Like we could use this one right here if you wanted to. You could also use probably right there too. But since we know for sure that this is darkened, let's go ahead and just use that one because we know for sure it's at a perfect intersection with the coordinate grid. Now I hope you know when you are labeling points on a graph that the x coordinate goes first and then the y coordinate goes second. So what that means is we're going to look at the x-axis first to identify the number that corresponds to this dot right here, like this. So here's the x-axis. Right there you'll see it's 16. It corresponds to where that dot is. So x is 16 at that dot. Okay, now to represent the y value, you're going to look at the y-axis. Okay, and you're going to see where it lines up with that dot. You'll see it's at 12. Double check it. Yeah. So this point, this coordinate, this ordered pair is 16, 12. Okay? And we're going to use that to help us find the unit rate of this graph. Oh, you know what? And as I got to looking closer, right there, that's not at a perfect intersection with the graph. It would be like actually up there, okay? So that's not an ordered pair that we can use to help us find the unit rate. But this one would have been. Okay, back to unit rate. To find unit rate, you just go y divided by x, okay? So I'll write that over here. Okay, so looking at this ordered pair, which one's the y value? Yeah, it's 12. And then the x value is 16. Now this is not the unit rate yet because we need to have 1 in the denominator for a unit rate. Okay? So to go from 16 to 1 using multiplication or division, well, you can multiply that by 1/16. You know, 16 times 1/16 is 1. But it might just be easier just to divide by 16. Dividing by 16 is the exact same thing as multiplying by 1/16. Okay, and let's also divide the numerator by that as well. 16 divided by 16 is 1. 12 divided by 16 is 12/16. And you'll see this fraction right there, we can simplify it. So think of a number that goes into both 12 and 16 without anything weird. 4 goes into both. So let's go ahead and divide the numerator by 4 and the denominator by 4 so that we get an equivalent fraction to this. 12 divided by 4 is 3. 16 divided by 4 is 4. So we have 3/4 over 1. Now, if you're not a fraction person, if you're not really liking to represent that as a fraction, to find its decimal equivalent, you just go 3 divided by 4. And when you take 3 divided by 4, you get 75 hundredths. Okay? So 75 hundredths over 1. This is cool, that's cool. Those all mean the same thing. They're all equivalent, okay? So take your pick. Okay, so now we've got to go back and think about a situation that could be represented by the graph. Is there something that, maybe let's deal with money, that might be easiest. Is there something that costs 75 cents per one item? So one thing would cost 75 cents. How about packs of gum? You know, if you bought a pack of gum, we'll just say it's about, you know, it's 75 cents, okay? So you can say, you can buy one pack of gum for 75 cents. So now that I kind of have my scenario right here, I should go ahead and label the axes with the quantities in our situation. So what helps us with that is looking at this unit rate right here. See that 75 hundredths, or 75 cents? That represents the money. And then that 1, it's pack of gum. And since the unit rate is y divided by x, kind of follow it along. Y represents the money. So the y-axis would be total cost, or money, or total cost in dollars, however you want to represent that. And then the x value for the x-axis, let's click here, follow, represents numbers of gum, numbers of packs of gum. Number of packs of gum. Okay? Now it says give the graph a title. And it's not anything random like we're going to call it something random. No, it's got to relate to the situation within your story. Okay? So since we're dealing with buying gum, let's just call it buying gum. There's a point on the graph. What are its coordinates? Okay, well the whole thing is points on a graph, but the darkened one, they want to know its coordinates. Well, we've already found that because that's what we use to help us find the unit rate. So 16, 12. And this says, what does it represent in your situation? So guys and girls, remember how I made you label everything? Well, this right here, that's the x value. This is the y value. So for the x value, what it represents, look at the x-axis, or look at the x part of your unit rate, okay? So I see that the x-axis, or the x part of my unit rate right here, represents the packs of gum. So this would mean 16 packs of gum. And then what does that y value, that 12 represent? Well, since it's in the y section, it represents total cost, okay? And look at y, yep, the cost, the money. So that would mean 16 packs of gum cost $12. Okay, and that cost is $12. $12 is the cost, okay, of 16 packs of gum. The next activity says, Tyler was at the amusement park. He walked at a steady pace from the ticket booth to the bumper cars. Folks, go ahead and underline right where it says steady pace and think about what that implies. When you're walking at a steady pace, you're walking at a constant rate. And that should hopefully relate to something called constant proportionality. Okay? Does that ring a bell? Number 1 says the point on the graph shows his arrival at the bumper cars. What do the coordinates of the point tell us about the situation? So go ahead and take a look at that right here. It says 40, 50. Remember that first part of the ordered pair is x and the second one is y. And to help us kind of decipher what on earth the 40, 50 means, you use the labels on the x-axis and on the y-axis. So the x value, let's look at the x-axis, that represents elapsed time. So that's time, the elapsed time, like how much time happened. And then the y value, look at the y-axis, and that says distance from the ticket booth in meters. So that would be distance. Okay, so to kind of put it into a sentence, it would be after 40 seconds, Tyler was 50 meters away from the ticket booth. Number 2 says the table representing Tyler's walk shows other values of time and distance. Complete the table. Next, plot the pairs of values on the grid. So you see we have the table right here representing the situation because it tells us that. And the first thing I want you to do is label that first column as X and the second column as Y. You'll see that those columns correspond to the axes on the graph. So X represents time in seconds, and it also represents right here the time in seconds on the graph. And Y in the table represents the distance in meters, and you'll see Y on the graph also represents the distance in meters. So you'll see we have a point at 0, 0. So let's go ahead and plot that right there at the origin. 20, 25. So x is 20, y is 25. 30, 37 and a half, or 37 and 5/10, same thing. So 30 is x, 37 and 5/10. So that's about 35, 36 or 7 and a half, about right there. Oh, see, that's not at a perfect little intersection. And then we have 40, 50. Oh, it's right there. And then we got a blank. It says 1 something. Oh, remember when the x value is 1, its corresponding y value would be the unit rate? Okay, and I can't really tell where 1 would be right there. I know this would be 5 because the intervals that we're jumping by are 5s. So 1 would be like right there, but it's hard to tell what the corresponding y value would be. So folks, let's go ahead and find the unit rate, okay? And to find the unit rate, you go y divided by x. So you can use any one of these values to help you find unit rate. Don't use 0, 0 because that won't help you out at all though, okay? So let's write that out. So unit rate is equal to y divided by x. And I don't care which one you want to use. Let's just use, I don't know, the first one. Okay, so y is 25. And since this is a situation, we're gonna label it. So the 25 represents the distance in meters, so I'm just gonna put meters, or m, okay? And then its x value is 20 seconds. So I'll write 20 SEC for seconds. That's not the unit rate though. Remember, we're almost there. We just need to get 1 in that denominator. We want it to say 1 second. We got to figure out how far he traveled in 1 second. So to go from 20 to 1, I would just divide by 20. And if you divide the denominator by 20, you got to do it to the numerator as well. 25 divided by 20, you can write it as 25/20ths as a fraction, or just go 25 divided by 20 in your calculator or in your brain, and you should get a decimal. And hopefully it's not like some repeating psycho long one or anything. Hopefully it's kind of a nice one, nice terminating one. Oh, it is 1 25/100ths. So 1 25/100ths meters per second. Okay, so here's the 1 second right there. And then the 1 25/100ths goes in this spot right here. So there you have it. Our unit rate, or our constant proportionality, is 1 25/100ths. So you can multiply all of those x values in the x column by 1 25/100ths to get its corresponding y value in the y column, because this is a proportional relationship. So number 3 says, what does the point 0, 0 mean in this situation? So what does that mean? Right there. You can also look at your table. So after 0 seconds, his distance from that ticket booth was 0 meters. Okay? So x, y, this right there means seconds, because it's all labeled everywhere. Okay, x and x. And then the y value is meters, or distance. So it will be distance in meters from the ticket booth. I'll just put booth. Okay? Now let's go ahead and let's write a nice sentence for that, okay? So I just wrote the point 0, 0 means he started at the ticket booth. Because at 0 seconds, you know, when he first started, his distance in meters from the booth was 0. So that means he started there at that ticket booth. Number 4. How far away from the ticket booth was Tyler after 1 second? Label the point on the graph that shows this information with its coordinates. Okay, so it says 1 second right there. Let's see if I can see that on the graph. Yeah, it's not there yet. That's why we have to label it. I don't see the 1 second and what it corresponds to. But guess what? You see it right there in the table. Right there, 1 second. And after 1 second, how far was he from that ticket booth? 1 25/100ths of a meter away. All right, let's go ahead and plot that on the graph. Remember, x is 1, y is 1 25/100ths. So x is 1, so like kind of like right there, and then y is 1 25/100ths. So it's like really, really darn close to that origin, okay? It's right there. So I'm going to go ahead and label that cute little point right there. Number 5, what is the constant proportionality for the relationship between time and distance? Oh, easy. You found it. It's right there already. You did all the work already. So let's make sure we label everything. So 1 25/100ths of a meter per 1 second. What does it tell you about Tyler's walk? Where do you see it in the graph? So what this tells us about Tyler's walk is after 1 second, he was 1 25/100ths meters away from the ticket booth. And where do you see it in the graph? Right there. Now for those of you that are ready for more, think about this scenario. If Tyler wanted to get to the bumper cars in half the time, how would the graph representing his walk change? How would the table change? What about the constant proportionality? So let's go ahead and I want us to start off with the table right here. Okay, so he wants to go that exact same distance but in half the time. So he wants to travel those 25 meters in half the time. So I would make this 10 seconds. So to go 25 meters, he'd be going 10 seconds. And this would be 15 seconds. This would be 20 seconds. And let's see, this would be half of a second. So if I change those values right there, what would that do to the graph? Well, it would make the graph, see how it's right there like that? It would make the graph steeper, okay? And how would that change the constant proportionality? That would make its constant proportionality 2 5/10 meters per second instead of 1 25/100ths meters per second originally. The next activity says, 4 seagulls ate 10 pounds of garbage. Assume this information describes a proportional relationship. Okay, so they're telling us, hey, make the assumption that, yeah, they're eating this at a constant rate, okay? Number 1 says, plot a point that shows the number of seagulls and the amount of garbage they ate. Well, we got 4 seagulls and they ate 10 pounds of garbage. Let's go ahead and look at the axis here. Number of seagulls is X. Okay, so in this case, the number of seagulls is 4. And then Y represents the pounds of garbage, and in this particular instance, it's 10 pounds of garbage. The abbreviation for pounds is LBS. Okay, let's go ahead and plot that. 4, 10. So X is 4, Y is 10, right there. Number 2 says use a straight edge to draw a line through this point and 0, 0. And the reason we're including that point 0, 0 is because remember how we're saying it's a proportional relationship? Well, a proportional graph is linear and passes through the origin. So we know it's going to pass through the origin. Now, number 3 says, plot the point 1, K on the line. What is the value of K? What does the value of K tell you about this context? So I don't know if you remember this, but K represents the unit rate. Okay? And remember, unit rate on a proportional graph can be found by looking at where X is equal to 1. Because that corresponding Y value, in this case it says K, is the unit rate. So when I look at the graph, I kind of look and I'm like, well, it appears to be like, well, it's not at a perfect intersection, so it's not like 2. So it might be a good idea to go ahead and put these values in a table to help us determine that unit rate. Another way that you can do this is by using just this point right there. We know for sure this point is on the graph. We can use this to find unit rate. Okay? So use either way, either method, use a table or just what you know about plotting points to figure out the unit rate. But always remember, it's always Y divided by X. So there I have the given information in my table right there. I've labeled my X and my Y columns and labeled what X represents and what Y represents. Okay? So I can use this value to find the unit rate. Remember, unit rate is Y divided by X. Okay, and you'll see that the Y value is 10. and that represents the pounds of garbage. I'll just put LBS, okay? And then the X value is 4, and that represents seagulls. So I'll just put gulls. And to find the unit rate, we want 1 in the denominator. So to go from 4 to 1, the easiest is probably just to divide by 4. You could multiply by 1/4, because 4 times a fourth would give you 1 also. But 4 divided by 4 is also 1. Okay, now we got to go 10 divided by 4, and you can keep it as 10/4 if you want. Or, I kind of like the decimal version, so I'm going to go 10 divided by 4. And we have 2.5. 2 5/10 pounds per gull. So each seagull eats 2.5 pounds of garbage. Now, if you didn't want to do the table, you can do this exact same thing that right there, what we just did, given that point on the graph. See how you have the y value and the x value? And you could go y divided by x. Just like that, you get the same exact answer, okay? And look, we get that unit rate. This also corresponds to the table. The x value is 1, matchy right there, and the y value is 2 5/10. So we put that right there. And I think they told us that they wanted it on the graph. Oh, plot the point. Okay, so let's plot that point. It would be x is 1, y is 2 5/10. Plot it on the graph. So x is 1, y is 2 5/10. So here's 2, and about right there, 2.5. Okay? What's the value of k? Right there. Or we can even put it right there. So many places. And what does the value of k tell you about this context? So specifically in the story problem, it tells us this. One seagull eats 2.5 pounds of garbage. We better put that in a sentence for them. Now I know they didn't ask you to do this, but I'm asking you. I want to know, are you able to write an equation to represent this proportion relationship? Remember, you'd start out with y equals k times x. That k represents the unit rate. So we already know the unit rate for this particular problem. Our unit rate was 2 5/10. So we'd insert that right there for k. So it would be y equals 2 5/10 times x. X stood for the number of seagulls, and y stood for pounds of garbage. And another way to write this exact same relationship here is like this. You swap the x and the y, and then instead of using 2 5/10, you use its reciprocal. Okay, so remember it's written like that. So when you flip over that number, it would be 1 over 2 5/10. Okay? And the y variable still represents the pounds of garbage. And the x value still represents the number of seagulls. Okay? This equation represents how you'd find values going from this way to this way. And this equation would help you find values going from here to here. Check out this summary right here. Okay, in general, when y is proportional to x, so when there's a proportional relationship, the corresponding constant proportionality is the y value when x is 1. So in other words, when x is equal to 1, and you know it's a proportional relationship, find where x equals 1, and the y value that goes with it, that is the unit rate, or the constant proportionality. So check it out here. Where is x equal to 1? Oh, year 1. Oh, right there. So that means this right here is the unit rate, also known as the constant proportionality. Oh, look, a table that represents the same exact thing. Let's see, find x is 1. Oh, there's x is 1, and boom, you're the unit rate. You're the constant proportionality, okay? So yeah, we take all those x values and we multiply them by 5/4 to get their corresponding y value because this is a proportional relationship, okay? Another way to write 5/4 is go 5 divided by 4, and you get its decimal form. So that's equal to 1 25/100. So I could also write 4 times 1 25/100 equals 5. 5 times 1 25/100 equals 25/4. 8 times 1 25/100 equals 10. so on and so forth, okay? These are your practice problems for interpreting graphs of proportional relationships. Number 1 says, there is a proportional relationship between the number of months a person has had a streaming movie subscription and the total amount of money they have paid for the subscription. The cost for 6 months is $47.94. The 0.6, 47 and 94 hundredths is shown on the graph below. Looking at the graph, X represents the time in months. So the 6, which is in the X spot, represents 6 months. And then the Y value is 47 and 94 hundredths. And the Y represents the cost in dollars. So when I read this, I can say, hey, 6 months cost $47.94. Letter A. What is the constant proportionality in this relationship? Well, we know that when X is 1, the corresponding Y value is that unit rate or the constant proportionality. And I don't see the corresponding value for when X is equal to 1. So we got to kind of find that in a different way. We got to use what they gave us. They gave us this information right here. Hey, look, there's an X, there's a Y. And hey, you use those to find the unit rate. Remember? Y divided by X. So let's go ahead and find that unit rate or constant proportionality. Okay, and that Y value is $47.94, and we're labeling that because it's money, and it's a story problem. And then the X value represents 6, and that 6 was months. Okay, and I abbreviated it. We want the unit rate, so we need 1 in the denominator. We want to say 1 month. To go from 6 to 1 using multiplication or division, let's just divide by 6. 6 divided by 6 is 1, so do that same thing to that numerator. $47.94 divided by 6 is $7.99. So it costs $7.99 per month for this subscription. What does the constant proportionality tell us about the situation? 1 month, we get it right there, costs $7.99 for this subscription. Letter C. Add at least 3 more points to the graph and label them with their coordinates. Well, since it's a proportional relationship, because it told us that, we know 0, 0 is on the graph. Now, we're supposed to find, 3 total. So something that might be helpful is, hey, let's put some stuff in a table, okay? So in our table, we know that X goes first and then Y. X is represented by months. Y is represented by the cost. You could also look at the graph. X is time, Y is the cost. All of these are just interrelated, okay? Okay, so we knew 0, 0 was on there, so no months cost no dollars. Well, 1 month, we knew 1 month costs $7.99. How much would 2 months cost? Well, remember how our unit rate is $7.99? So you're multiplying all those X values by $7.99 to get their corresponding Y value. Okay, 3 months, let's do 4 months, 5 months, and 6 months. We knew 6 months cost $47.94. I can put that one in there too. So how much would it cost for 2 months? $15.98. How much would it cost for 3 months? $23.97. 4 months would cost $31.96. And 5 months would cost $39.95. You'll see that we multiplied all of those X values by the constant proportionality, or that unit rate, to get their corresponding Y value, okay? Oh, and now we have to add those points to the graph. Okay, so, well, none of them are at perfect little intersections because they all have decimal values. So let's go ahead, at least put the unit rate on there, 1 and $7.99. So 1 month is $7.99. So let's see, what is this one jumping by? Tens, 10, 20, 30, 40. Okay, so 1 month is $7.99. So it's approximately, that's about right there. Almost a 10. And then 2 months is $15.98. So 2 comma 15.98. So that's at 15, so a little bit past it. 3 months costs $23.97, so almost 24. Okay. 3 months. About right there. Now this is supposed to be linear and pass through the origin, so you can see my dots are a little off. Okay, so now when we connect the points, it's linear and it passes through the origin. Okay. And I'm thinking with this particular context, I don't know if we can pay for like 3/4 of a month, or, I mean, I don't think you can call the subscription service and be like, you know what, I only want it for 5/6 of a month or a fractional part of a month. So, you know, I don't think I'm supposed to connect those dots. We can only have whole month intervals, right? So in this case, I wouldn't connect it, but I just connected it for the sake of showing you, hey, this is linear and it passes through the origin. Write an equation that represents the relationship between C, the total cost of the subscription, and M, the number of months. Okay, hold on. We know it's a proportional relationship, so we know that the relationship is represented like this in an equation, right? Okay, the unit rate was $7.99. We knew that X represented month. We knew that Y represented the cost in dollars. But now they want us to use different letters. So C is the total cost of the subscription. That's cost, so erase your Y and put a C. And then M represents the number of months. So that's why I got to erase the letter X and put an M. Okay, there's our equation. And another way to write this is swapping your variables. So M goes first, C goes second, and then writing down the reciprocal of the unit rate. So remember, if it was like this, that's the same thing. Now we got to flip it over. That's the reciprocal. Okay, M still represents months, C still represents cost. These are two equations that represent the exact same thing. This one just shows how you get from this to this. This one shows how you get from this column to this column. Because you'd multiply your Y value by 1 divided by 7 and 99/100ths to get the corresponding X value. Okay. Number 2 says, the graph shows the amounts of almonds in grams for different amounts of oats in cups in a granola mix. Label the point 1K on the graph. Find the value of K and explain its meaning. Remember, K means unit rate. So we got to go ahead and, well, we got to label the point 1K. So let me see, 1K. All right, it's not at a perfect little intersection with the coordinate grid, so I would just be guessing. I'd be like, oh, it's like 1, maybe 25 or something. That's my guess. But since we don't know for sure, we got to go ahead and do some math to find the unit rate. And remember, to find unit rate, it's Y divided by X. But you'll see there's no darkened points right here, so you got to kind of do some thinking. Find a point, you know, an ordered pair right at a perfect little intersection with the coordinate grid, because then you would have whole values, okay? So let's see. Keep going, keep going, keep going. No, not quite. Ooh, boom, right there. See how it's at a perfect intersection? I can use that point. Keep going. What else are other options? That one? Nope. Oh, boom, right there. I can use either one of those points. So this point right here is 250. This point right here is 4/100. Oh, you'll see those points grew proportionally. We just times this by 2 to get this by 2 to get that. Yeah. We also know this is a proportional relationship because look at that graph. It's linear and passes through the origin. Okay, pick either one to find the unit rate. I'm going to use this one. So y is, okay, let me label it because it helps. If you use this one, label it too, it's helpful. Okay, y is 100. And label it y 100. The y-axis is almond grams. So I'm just put grams. And then x is 4. But what does the 4 represent in the context of the story? X is 4. Look at the x-axis. Cups of oats. Okay. We want 1 in the denominator, so we want to say 1 cup oats. To go from 4 to 1, using multiplication or division, it's easiest just to probably divide by 4. Do that to the numerator also. 100 divided by 4 is 25. So 25 almond grams or grams of almonds per 1 cup of oats. There's our unit rate, also known as K. Okay, what was the question again? Label the point 1K on the graph. Oh, okay, so our point, remember x, y, that's how you label points. So x was 1, y is 25. Okay, so x is 1, y is 25. Oh, I was right. It was right in the middle. But we weren't allowed to make that assumption though, because it was kind of hard to tell. So that right there is the unit rate at 1, 25. All right, now let's make sure we answered all the questions. Oh, we have to explain its meaning. We have to explain what that unit rate means. And I'm drawing your attention right here because remember how you make you label everything? This really helps you when you're writing the sentence to explain the meaning of the situation, okay? So it says 1 cup oats, 25 grams of almonds. So here's a good sentence for that. For each cup of oats, for each 1 cup of oats, there will be 25 grams of almonds in the granola mix. Number 3. To make a friendship bracelet, some long strings are lined up. One of these strings is chosen and tied with each of the other strings to create a row of knots. Then, another of the strings is chosen and knotted with each of the other strings to create the next row. This process is repeated until there are enough rows to make the bracelet to fit around your friend's wrist.
Make this knot, and then this will be your new base string. And same thing, you'll do a forward knot on this side. Pull it up. This will be your base string. You'll do a knot on this side, like this. Pull it through all the way up, and then you're just going to keep alternating. So now I'll have my blue and do a knot, and then my yellow and do a knot, and basically you just do this all the way until you have the length that you want. So you could go a little bit longer for an anklet, size of your wrist for a bracelet. You could even make this into like a choker or something, but you just keep going back and forth all the way until you finish.
Are the number of knots proportional to the number of rows? So the answer to this is yes, it's a proportional relationship. Since each row will have the same number of knots in it, the number of knots will always be a multiple of the number of rows. Number 4 says, what information do you need to know to write an equation relating two quantities that have a proportional relationship? Well, remember, the equation for a proportional relationship is represented by y equals k times x. That k is the unit rate. So things that you need to know in order to represent a proportional relationship with this equation is you would need to know what the constant proportionality is, and you also need to know values for what you're representing. You know, what would be the x value, what would be the y value, because that would help you get the unit rate, since unit rate is y divided by x.